A and B are two events. The probability that A will occur is 0.4. Let's write it on the side. And the probability that the event B will occur is 0.3. Let's write it there as well. The probability that either A or B will occur is 0.58. The probability of A or B is 0.58. Another way to write it is like so. Remember that the mathematical symbol for or is this U-looking symbol. Proper stuff. Let's attack the first question. 8.2.1. Are events A and B mutually exclusive? Justify your answer with appropriate calculations. For you to prove that two events are mutually exclusive, you can either prove this, the probability of A and B equals 0. If you're able to prove that two events, the intersection of two events is 0, then you would have proven that the two events are mutually exclusive. Or you can also prove this. If you can prove that the probability of A or B equals the probability of A plus B, then you would have proven that the two events are mutually exclusive. Either prove this or that. Now, what we have so far, we have the probability of A, the probability of B, and the probability of A or B. So we could use this. We could use the second condition. Let's see if that is the case. We are told that the probability of A and B is 0.58. Okay, sharp. Now let us find the sum of these two probabilities and see if we get the same answer of 0.58. If the answer is 0.58, then we can safely conclude that the two events A and B are mutually exclusive. So let's go. Let's now look at the probability of A plus the probability of B. The probability of A is given to be 0.4. Let's go ahead and do that. 0.4. Then the probability of B is given to be 0.3 as given there, which then gives us an answer of 0.7. So the two events A and B are not mutually exclusive because the probability not mutually exclusive because the probability of A or B is not equal to the probability of A plus the probability of B. So the two events are not mutually exclusive. Easy peasy lemon squeezy. Okay, so that's about that. And then the second one says 8.22. Are the events A and B independent? Justify your answer with appropriate calculations. Two events A and B are independent if and only if the probability of A and the probability of B equals the probability of A times the probability of B. Okay, so now let's first of all find the probability of A and B. Okay, how do we find it? We're going to use the classical formula for probability to find that. The classical formula for probability, which says the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Ne? So we're already given this probability, that probability, that probability. All we have to find is this. Okay, let's go ahead and substitute. The probability of A or B is given to be 0.58. As we've already established, the probability of A is 0.4. That of B is 0.3. Okay, then this will simplify to 0.7 minus the probability of A and B. Then let's take this to the other side so it becomes positive. And then let's take this to the right hand side. And then obviously when it does that, it becomes the opposite of what it was before. So since it was positive, it now becomes negative. So this will give us an answer of 0.12. Okay, so the probability of A and B is 0.12. Just a reminder what we're doing. Remember that we are checking if the two events A and B are independent. So for you to check that two events A and B are independent is for you to prove that this A and B is equal to that product there. If they're not equal, then the two events are not independent. So already have the value of, or we just found the value of the probability of A and B. Now let us find the product of these two. Let's multiply the probability of A and the probability of B. Probability of A is 0.4 and the probability of B is 0.3, which gives us an answer of 0.12. So this is equal to that. So therefore, you can safely conclude that the two events are independent. Why? Because the probability of A and B equals the probability of A times the probability of B. Easy peasy.